Hi, everyone. Thanks for coming to Web3 for Fun and Profit, Agency, Openness, and Re-Decentralization. My name is Brooklyn Zelenka. You can find me anywhere on the internet as Xpeed. I am the CTO at a company called Fission. We are a protocol engineering team focused on the future of the internet, which is to say, Web3. We do things like make it possible to write entire, modern web applications, but without the server. So everything happens locally, ID, auth, storage, collaboration, all that stuff. And as part of this work, we're involved with a lot of the spec organizations, including the Decentralized Identity Foundation, which does decentralized identity, distributed auth, and offline capabilities. I used to be a core developer with Ethereum. If you're not familiar with that project, it is the world's second largest blockchain. I was mostly focused on the virtual machine. With that work, I have now wandered over into Filecoin and some other areas of Web3 as well. And because this is CascadiaJS, some of you may actually be around for when we start doing meetups again. So I run the Vancouver Functional Programming Meetup and Code and Coffee. If you happen to be around as things open up, we'd love to see you. So Web3, this is a term that's been around for a little bit. Here's the last 5 years of history, up to about when I was asked to give this talk. Certainly not a new term, has been around for a while, has been used by different organizations for different things. But then in the past couple of weeks in particular, something happened. Honestly, I don't even know what, but this term has really taken off. So, you look at Twitter and there's hashtag Web3, in lots of places. So because of that, I've had a lot of people ask me, what is even happening? Should I be excited? Should I be terrified? Have I missed the bus? Should I just ignore the whole thing? Also, isn't Web 3.0 the semantic web, right? Like, it sounds like it's been repurposed. Yeah, the term has been. There is so much happening in this space that 20 minutes is just not possible. So my goal here is to give you a high-level overview, talk about the goals of the movement, and give you essentially a handy map for and framework for thinking about how all the different technologies fit together, the existing stuff, to be able to evaluate if things are Web3 as they're invented in the future as well. I will not be talking much about decentralized finance. The title is obviously a little bit tongue-in-cheek. There's absolutely fun and profit to be had around here. I'm not going to be giving anybody stock tips in this talk. So we'll be talking about Web3 sort of broadly. DeFi has really funded a lot of the core R&D in the space. But there's so much more to that. There's lots written about DeFi, so I don't feel like I need to go into it in depth here, though I'll talk about it from time to time. So let's get started with what even the heck is happening. Don't panic. Remember that this has all happened before, and this is all going to happen again. This is the normal crank of the wheel, right? It's easy to point at these old articles and laugh at, of course the internet was going to be around. Well, I remember 10 years ago when NoSQL started to become more of a thing, and people weren't sure if it was just going to completely replace relational databases or if it would just disappear. And there were people really entrenched on both sides of this camp. Both are around, and they're both available today for you to use or not use, based on what your project needs. The same is true with all these Web3 tools. You don't like blockchain? Unfortunately, it's here to stay. Decentralized identities, verifiable credentials, public key infrastructure, all of this stuff is sticking around. People have mixed feelings about the name and the terms being used in general, right? It feels like, needless jargon, right? So web geeks need to practice the art of plain speaking. But if you may have noticed in there that that's actually from 2006 and is about Web 2.0, right? And is about these jargon terms like wiki and blog. Yeah, a lot of these things sound like buzzwords today, but will enter sort of the broad lexicon over time. Maybe the terms will change. I don't know, but these basic concepts are going to find their way into regular speech. Because of that, because things are so early, it can be sometimes difficult to explain to people what's happening. So in the same way that Web 2.0, we need to create these diagrams, and this is from a 5-page O'Reilly article about all the disparate pieces and participation and publishing and all of this stuff. Web3 has the same problem today, where we need to be able to place a box around it and say these are the concepts. So to try to do that at a very high level, Web3 is a technological and social movement characterized by openness, interoperability, and user agency. Now, those are all nice things. It's essentially motherhood and apple pie. But if we look back into history, the web originally was about these things, right? These were the 5 core values, including decentralization and consensus and universality. And those existed all throughout the OSI stack, right? From the physical layer all the way to applications. No one in Web3 would disagree with, I think, any of these principles. People, in fact, would say that we're returning to the original intention of the web to large extent, because it feels like we've gotten away from these a little bit. You'll hear people in the space often say and try to justify things as, but it's decentralized. It's like Twitter, but it's decentralized. Well, decentralization itself isn't the goal, right? It's easy, because decentralization is such a powerful concept, to forget what it's actually about, the actual intention that we're going for, right? Decentralization always serves a goal. With the ARPANET, it was the Cold War, and so they were afraid that their data center would get atomized and they wouldn't be able to talk to anybody. So they decentralized that network because it made it more resilient at the network layer. So let's look at our different kind of network topologies. Totally centralized. Mainframes, basically, right? The internet isn't even really, most of that stack is not centralized. So this is where we have this pink, main provider, and then a lot of consumers around it. This is, you want to get a government issued ID, you can only get that from the government, and so you have to go through them. You don't have any choice. Decentralized networks, most of the internet works this way. Even the things that we would consider more centralized are able to talk to each other. You're able to, at minimum, link out to other pages. And often they will provide webhooks and things for each other. So, you're on GitHub, you have a link out to Twitter, and you also have a webhook that shows up in, Discord or Slack that shows all of the activity for your project. And finally, we have fully distributed systems. This mesh network, which is highly, highly resilient, right? We can take out a bunch of these and you can still route to almost everyone else. And anyone can be a consumer or a provider, right? So even if we break this network apart into smaller groups, they're not completely out of luck, right? Some of these might be more connected or have more resources available than others, but still fundamentally, even if those disappear, anyone can step up and provide. In a decentralized network, GitHub goes down, your WebSockets stop working, you stop getting those nice updates, but you can still fall back to using Git directly and set up a Git server, and you don't get all of the niceties but of hooking into everyone else, but you can still do that, and all of the other services remain unaffected. So Twitter continues to work, Slack continues to work. In a fully centralized system, removing this one providing node, which again doesn't have to be the network layer, this could be a critical application. If that critical application goes down, large parts of your functionality go with it, right? You have nowhere else that you can get these things. So, obviously Facebook had a little mishap with the Border Gateway Protocol recently, and that took down, a big chunk of the internet and the all the things that the 2 billion or so people that rely on them use. This runs the whole way through the stack, right? So Andreessen Horowitz, big VC firm, think that at the network layer, we're going to see the same thing because with the rise of IoT, geospatial data from self-driving cars, the metaverse, and the seemingly inevitable smart glasses, the volume and rate of data that we're going to be interacting with is just too much to send all to US East 1, right? So peer-to-peer and distributed computing is coming for purely practical reasons, in addition to wanting these warm, fuzzy values as well. So, spending a lot of time talking about the differences between the Web 1, 2, and 3, let's look at them directly. When we moved to Web 2.0, we didn't throw out the original web, right? We built on top of it. We now had more capabilities. We still had hyperlinks and HTML and CSS and all these things, but we had the ability to do even more, like, subscribe, share, right? And with Web3, it's the same. All those things are sticking around. We just have more capabilities now. It's not against, it's with. It's an and, not an or. The web was fundamentally a consumer model, right? You could put a website up, but you needed to have the relevant technical background. Web 2.0, we made it much easier for people to interact directly, right? Again, adding comments, writing blog posts, sending tweets, all of that stuff. And with Web3, we're making people capable of owning, assets, but also things like their own data and their identity. Content was static. Web 2 became interactive, and Web 3, generative and repurposable. Interop, it was possible, but it was hard, right, originally. Web 2.0, we have pre-negotiated tokens. And with Web 3, we don't even need to pre-negotiate because the data lives more or less out in the open, most projects. And so we can have permissionless innovation. And finally, we have infrastructure, which was self-hosted. You had a beige box somewhere. Maybe it even had a name that would serve your website. Web 2.0, we had trusted providers, i.e. the cloud. And with Web 3, we have the trusted commons. And monetization, closed e-commerce. And then the switch to, somewhat controversially, ads and attention. And finally, now, open markets and micropayments for the things that need payment. So let's start by talking about agency and ownership. So again, this isn't only in the financial sense, this is also in owning your own digital life. And the core idea here is to lower the barrier to entry and give people more control, right? Give users agency. They should have the ability to participate, not just as consumers and creators, but also as providers. Why can't we use the additional capacity on our laptop to provide compute or storage? We should, right? The option to leave. Well, if I don't like my provider, I should be able to pick up and use a different provider without having to rewrite my app, without even needing to have a technical background. I should just be able to say, well, who wants to provide this for me, right? So pushing more into the protocol layer. Control of our own data rather than having somebody else manage it in a data center somewhere, and being able to prove our ownership over it with digital scarcity. So this isn't a new concept. It's just getting a lot more attention these days. Using things like public and private keys to prove that you have some unique access to a private key means we can prove that you're you. This is the same way that you dial into an SSH, to a server over SSH or sign your Git commits, which you're hopefully doing. You can then create and manage an identity for yourself. So the document for that looks a little bit like this, top right one, and it's also getting used by governments like the BC government, the Ontario government, because it is more secure, more provable, and very flexible, and anyone can generate one, right? So now the government can say, oh yeah, whoever controls this private key, yeah, they're able to drive, or they're over 18, they're allowed to vote, whatever the thing is, right? It also lets you own your own data because now you can do key management. We're baking in hardware security modules where we can start storing keys. My phone now can store keys for me. So key management is increasingly becoming solved. And because these are private keys, we can prove that they're unique unless I'm sharing them with somebody, which is assumed in the model that we're not doing because you essentially don't want somebody to get into your stuff. So why would you, right? User-controlled data, in the same way that we used to store credit card information in a database, well, why are we storing personal information in a database? Right? This has become such a problem that we need regulation, GDPR. There's a bunch of regulations around the world that say, if you're collecting personal identifiable information, you need to manage it in a particular way. Well, if you let users manage their own data, so either they have it locally and you provide them the rest of the application, or it is encrypted at rest and now they can store it anywhere because they're the only ones that can read it or whoever they give access to, then you don't have to worry about GDPR, right? So definite benefit for the developer and for the user because now they have control over who sees their information. With all this public key talk, we can also radically simplify and reduce the complexity for auth. So this is a typical OAuth flow, something that you'd see in most apps. And I can't remember the exact number of steps here, but let's call it's about 11 or so, I believe. And there's lots of back and forth and refresh tokens and all of these things. Because it's based on passwords. Well, when we move over to public key infrastructure, we can radically simplify this picture. And so it even places the user in direct control by saying, okay, well, we don't need an authorization server anymore that manages some of this key material. We can just say, okay, well, I'm going to assign a certificate to the application. It's now allowed to do things with some subset of my data. And then from, until that certificate expires, it's allowed to do things with that, with those resources. And this doesn't even have to look all that complex, right? JWTs, the same thing you use for OAuth, can encode this information. So here's a DID that a user owns and controls. Here's the things that the certificate's allowed to do. So we're allowed to overwrite this Boris person's photos and send email on their behalf. And the way that we know that anyone can check that the certificate allows that is we have another base64 encoded JWT signed by this Boris person, allowing them to, showing that they've delegated these rights to this certificate. So everything is just completely self-contained. It doesn't have to live in a database somewhere. Finally, interoperability. This is a CryptoKitty. They're kind of cute and essentially a digital pet. This is the data structure that represents it, and especially the one that we're interested in is this, randomly generated number that gives us its attributes. So, some portion of that, those ones and zeros say, this one's going to be purple and, it's going to have a little, fluffy thing on its head, all of that. But because all of this data is stored in the open, so in this case, it's on a blockchain, but this, you could distribute this over DNS and text records, you could do any of these things. Anyone is able to repurpose it. So here's Kitty Race. Something that was not intended originally with CryptoKitties, and you can take your kitties and race them. You can build card games, and then fight your kitties against each other and reinterpret that same DNA as, attack and defense and elements and all these things. So we have this very fast innovation model where people can just take things and run with them. Right? It's open source, but at the data layer. It's open data. So all of this is trying to lock the web open this time, right? And this time we mean it. It's not like we didn't try to do this before. So given that human nature is to hand over, for convenience sake, trust to others, how can we make it so that more people participate and keep it in this, incentivized to keep it in this open model? Well, commons networks are the way to view networks that do these things. So open source used to be called commons-based peer production, which says lots of people will work on it, everyone benefits on it, and then anyone can build on it, even if they're using it for revenue. It doesn't matter. Well, we can take this and extend it for this new world and say that it's also owned by everyone. By participating, regardless your intention, you strengthen the network for everyone. Right? So that we have this really nice symbiotic relationship, this nice virtuous cycle between these two halves. We want to have really good scale on the internet. But typically, as we add more participants, the efficiency drops. In fact, it drops a lot, right? Because we're going to wait for data from somebody else, or we have different views of the data and we're trying to synchronize ahead of time. So there's only so many participants before we start to lose efficiency. Well, we can actually make it better than this linear ideal. We've already seen this with things like BitTorrent and IPFS. The more people that are downloading the Ubuntu ISO, the more people then are also serving small chunks of that. You don't have to have the whole thing, right? And so the more people participating for their own ends, they're actually improving it for everyone else. This means that we can make very resilient systems that work for everyone, where you don't have to understand deeply the entire stack, right? We used to have to build computers from scratch, and now we're moving into this era of the commons. The cloud totally helps. Serverless, we're abstracting even more away. And now with the commons, everyone is both a provider and a consumer. So what now? Well, we have this ever-growing toolbox, right? We have our cloud and our serverless, our peer-to-peer networks, our local first, so like your native apps and offline first capabilities, and now commons networks. So you have all of these in your toolbox. You don't have to get rid of anything. You just have more things that you can reach for. Places to start, Protoschool has a particular view on the space, but it has a lot of the basic data structures and concepts that you'll interact with. JS IPFS. IPFS is meant to be a decentralized HTTP replacement. This works in the browser. Nice way to get started and an easy way to think about things if you're an existing web dev. Ethereum for blockchains is the most popular one, and there's a lot of resources for it. AutoMerge, if you're doing compute and storage across many devices, especially if they are going to be offline for some period of time or where the user wants to control their data and only share it with a few people, then this can be a good library for doing the sync. And UCANs, which we looked at earlier, the authentication distributed auth system. So Web3, openness, interop, user agency. You haven't missed the bus. It's moving fast, but it's still very, very early. There's lots to do, and lots of it is low-hanging fruit. So please come, get involved, build something, and I'm happy if anybody wants to reach out and ask deeper questions. There's my contact information. And yeah, thank you very much for coming.
All right, and thank you, Brooklyn. I've been seeing Web3 all over the place, and this was a very good way of sort of making it make sense. I really liked, when you're talking about the open web, and this time we mean it.
Yeah, it's not the first time we've tried this, right?
Yeah. So with this distributed model, what is the role of servers in Web3?
Yeah, so a big trend overall with Web3 is liberating both compute data and identity from any particular location. So there's a lot of people who only view it as in the blockchain or only in the browser or only self-hosting and running something locally. But you can move across these different areas. Servers, let's say you have a server running today, you can absolutely run this stuff on the server, especially the identity component is a nice place to get started. and say, okay, well, I'm going to give the user the ability to manage their identity. Again, as I mentioned, the same way that you sign Git commits. And then when it goes to the server, well, now you're not the only one that runs their entire identity, right? So backing things up to the cloud, still entirely possible. Interacting with user identity, totally doable. And having even just directly machine-to-machine Web3 services, entirely possible. So it's a very, very broad space right now.
Oh, all right. Well, so it sounds like a lot of this, has a lot of people working together, a lot of interop. And, let's say I'm just getting started and I just want to build something for myself. How do I do that without being part of this giant thing?
Right. A lot of these projects are really meant to work, sort of at instrument scale, out of the box, and they do scale all the way down to a single individual user. The main difference being that you could then take this and plug it into other things. The easiest way, again, is to start with identity. And then keeping things local first. So instead of saying, well, step one, I have to write, deploy, maintain a server, using some of these, especially the packages that I mentioned near the end of the talk, things like auto merge, things like UCANs, and using some of the more recent browser APIs like Web Crypto API, IndexedDB, things like that, you can build an application that runs entirely in your browser just for your use case, and then also sync that data across your devices without needing these extra steps. So at Fission, we've built a framework for this called Web Native. We've had people build stuff for like them and their roommates. And again, there's no server required in the middle there. So it does really scale all the way down to individuals or like, even people in a household.
All right. Well, that's all the time we have for questions. I really thank you a lot. And I hope people will head on over to the AMA section because there's a discussion going on right now. And we're going to hand it off to Ian Sutherland, who's going to talk about developer experience for internal teams.